Basically, when you are asked to given the task of making a solution, you need to identify what kind of solution you're making. Okay, so if it's a stock solution, dilution problem, so you're asked to make a dilution out of a stock solution, you have to use this equation. Okay, initial concentration of stock times its unknown volume equals the solution you're making, its final concentration times its final volume. Okay, and the equation, so normally you solve the equation for VI, unknown volume of the stock solution. Once you determine how much of a stock solution is needed, then you just need to dilute it by adding the water to make the final volume. Okay, that's how you make it. If you're dealing with the molarity solution problem, you just need to multiply them all. The concentration of your molar solution times how much of that you need to make in liter. So concentration is in mole and the volume is in liter, and then with the molecular weight, gram per liters per mole. Okay, so then it'll let you know how much of the solute you need, and you have to mix that solute with a certain amount of water that will give you the combined volume. It will be the defined volume you're making. Okay, make sure it's not the water of that volume. It's the last volume of the water added to the solute. When you combine the volume, that combined volume will be the volume you're making. Okay. Normality solution is the same way, but you first need to convert normal to mole by looking at the equation of that acid. Okay. Now percent solution, you have to change the solute in 100. Okay. So whatever the percent is, okay, change that. If it's 2%, it's 2 over 100. Okay, if it's 20%, it's 2 over 20 over 100. Okay, you multiply that to the final volume. Okay, then that will give you amount of the solute you need. So concentration in decimal equivalent or fraction, and you multiply that to the final volume, and that will be the amount of solute you need. And if it's mass of the solute per the final volume, and then you've just figured it out by multiplying it, concentration times volume, that will give you the amount of solute you need. Okay, and when you do that, the important thing that you need to make sure is that you will have to match the unit. It's gram per mole per liter. Okay, but if you're making maybe milligram, you have to convert that gram to mil. If you're making millimolar solution instead of mole, again, that's a 1,000th liter. Again, if you're making milliliter instead of liter, you have to consider it as well. Okay, keep it in your mind. And then once you make a solution, sometimes you have to sterilize your solution to be able to keep that, clean for a long time. Okay, so then how do you sterilize your solution? There are various ways of sterilizing your solution, but one of the common ways is the autoclaving your solution. So autoclaving means you are treating your solution with the steamed heat for a long time. Okay, then that steamed heat will make your solution clean, because steamed heat will kill whatever the germs is in your solution. So this is actually from your supplemental handout, autoclave machine. So you have a door in this stainless metal chamber. You place your solution in there and close the door and lock it up, and into that chamber you introduce pressurized steam. Steam is high vaporized high liquid, high heat liquid. So you keep that your solution in that condition for a long time. Then whatever living things will be killed by the autoclave. So that's what it is. Okay. So autoclave guideline, how you use it, steam sterilization method. Please take a look at this. Okay. And how do you know if the autoclave did its job? Meaning, did it keep the high temperature? Did it keep enough pressure for a long time? Okay. How do you validate that process? We have some things that you can use for that. We have a Boidic autoclave tape that changes color after autoclave is done. You can place that tape on the top of your solution bottle and see if the color change is being made. You can also measure the heat temperature maybe of the autoclave cycle, or there are another things like you can use, like spore test strip, or maybe ampules that you can use. Okay, you can also measure the pressure during the autoclaving cycle. Then how to sterilize heat-sensitive material. So what if your solution has some heat-sensitive material? You cannot heat it. For example, maybe your solution has proteins, antibiotics, vitamins, and serum, and volatile chemicals. Then how do you sterilize it? So you cannot use heat then, right? You have to use something else. Then you may have to use normally filtration instead of heat-based sterilization method. So filter that has small pores will remove any living cells, like a 0.2 micron pore diameter filters can efficiently remove all the living cells, bacterial cells or eukaryotic cells. So you can filter sterilize your solution instead of autoclaving. Okay. And among different solutions you'll be making, there are some things called growth media. Growth media are solutions that can support growth of certain cells. So you may be growing some cells for your experiment. If you are, for example, trying to isolate some DNA out of cells, maybe bacterial cells, first you have to have enough bacterial cells made to be able to isolate DNA molecules out of those cells, right? So for that you have to grow bacterial cells long time, maybe overnight. Okay, and how do you grow bacterial cells? You have to provide the food, you have to provide good temperature and good physical condition, maybe like oxygen, for the cells to grow. So normally cells grow in a medium, growth medium. Growth medium can come in as a solid form or solution form. Okay, so we'll talk about the solution form of growth medium. Okay, so normally that solution form of growth medium contains nutrients, like I said. So the cells can eat up those nutrients and break them down. When they break them down, they can maybe capture energy. Not only that, they can maybe use some broken down molecules as their building blocks, like sugar or maybe amino acid, things like that. Also, you need to provide the correct amount of salt, because too much salt, too little salt is not good for the cells. Cells will die. Okay, vitamins are trace amount of elements that are required for the growth of the cells. Hormones are needed, of course, sometimes. Antibiotics, if you want to grow only your cells, nothing else, sometimes antibiotics help. So these things are commonly found from growth media. Okay, so for this lab, you are tested with making a solution called 2XYT. Okay, YT stands for yeast extract and tryptophan. Those two components are mixed up together. Okay, that's what you're making. So the growth medium for E. coli is a gram-negative bacterial cell. Okay, so if you're making 1 liter, which is 1,000 milliliter of this solution, normally you add about 16 grams of bactotryptophan, which is a bunch of amino acid. Okay, and 10 grams of yeast extract. Yeast is a fungi, unicellular fungi. Dead bodies of yeast cells are good nutrition source for the bacterial cells. Okay, so mix them together, 16 and 10 grams, and then add a little bit of salt. That's about 5 grams of sodium chloride, and then mix about 900 milliliter of water and dissolve them all. Once they are all dissolved, you need to check its pH, the solution pH, because cells prefer neutral pH around 7. Okay, it shouldn't be too acidic or too basic. So if the pH is too low or too high, you need to adjust that by adding base or acid. So in this case, normally you have to bring up the pH, because these are kind of acidic, by adding sodium hydroxide solution. So how do you check the pH? You should know how to use a pH meter. Okay, I am giving you SOP on how to use a pH meter in your course shell. Take a look at that. Once the pH is adjusted to 7, then you need to check the volume to make sure that your final volume should be 1,000 milliliter, which is 1 liter. Okay, if the volume is less than that, what you need to do? You have to add water more to get the final volume to be adjusted to 1,000 milliliter. Okay, once that's done, then you're not done yet. You have to autoclave it, sterilize it by putting your solution into autoclave machine. So because you're going to use that for next lab, you have a bacterial growth lab. Okay, that's what you do. In good solution making, so whatever solution you're making, these are the tips for making good solutions. Make sure to use clean rinsed glassware, flask or beakers, whatever. There should be all clean ones. Remember the steps. Less amount of solvent you're studying. You're making 1 liter. You are not going to pour 1 liter of water and mix up with the solute. Then you're going to exceed the 1 liter, right? You start out with maybe 800 ml or 900 ml. And once the solutes are fully mixed up and dissolved, okay, and then you need to check the pH, and then final step will be the final volume check, okay, by adding water, okay. And then when you check the volume using a graduated, volumetric device, make sure that you read the meniscus. Meniscus is a crescent moon shape, surface. You normally measure the lowest point of the liquid to measure the volume. And then once solution is made, you label your solution within a container. A solution name, concentration, your initial, and the date when it's made, so everybody else can understand. So what do you need to do for this lab? So complete the solution making practice worksheet. So that's 5-point assignment. And then there's another assignment that is the 2xyt medium batch record. You need to follow the batch record to make the solution. That is your hands-on exercise in the lab. Once you are done with the solution making, we'll autoclave it and you'll fill out the batch record. So that's it for this lab.